So this is the problem C, even subarrays of code forces around 841 div2. So in this problem, you are given with an array A. So we need to find the number of subarrays whose XOR has even number of divisors. So in this, what we will do is we will just find the number of subarrays which are having odd number, which are having the XOR, uh, which is having odd number of divisors. So for that, we need to subtract the, for getting the overall answer, we will subtract the n into n plus 1 by 2, that is the total number of subarrays minus uh, the uh, the subarrays which are having the XOR which is having odd number of divisors. So this will be our final result. So what we will do is we will write we will define a function fi. So fi will be a1 XOR a2 XOR till ai. So for a subarray that is from L plus 1 to R, the XOR of that subarray will be FR XOR FL plus 1. So what we will do is we can notice from here that the numbers, that is 1, 4, 9, 16, that are perfect squares are only having the odd number of divisors, because in this if the number is a perfect square, then like 1, 2, 3 square root of n till n. So here if we find a number which is divisible by n, then we can find a number here also which is equals to n by that number. But if the square root of n is divisible by n, then we cannot find, then this the square root of n into square root of n is only n. So if the square root of n is divisible by n, that is the square of square root of n is n, or n is a perfect square, then it will be having the odd number of divisors. So for that we can iterate only, this will be around a square root of n. The number of these and the number which are perfect square will be around square root of n. So we will iterate over all these numbers and we will find the result. So we will be using one property of XOR here, that is A XOR B equals to C. So B XOR C will be equals to A, and A XOR C will be equals to B. This implies this. This implies this. So we will use this property. So for getting the number of subarrays, we will look upon this. Like suppose we define that the subarray will be ending at A4. So the total number of subarrays the subarrays which are ending at A4 will be this, 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 and this. So we need to find out of these four how many subarrays are having the XOR which is having the odd number of divisors. So we can easily find that like the rightmost element will be A4. So we will write F4 XOR FL equals to X. So here we need that X should be a perfect square, because if X is a perfect square, then only the XOR will be having the odd number of divisors. So we need to find the number of L's which satisfy this condition that X is a perfect square. So as from the property which we have discussed earlier, we can write this equation as this equals to FL. So we need to find the number of L's which are satisfying this equation. And for X, we can iterate from 1, 4, 9, 16, 25, and all the squares till square root of n. So for particular, we will find the number of L's. We can find the number of L's by storing the frequency in the frequency array and adding it to answer. So like this, we will iterate from 1 to 7 and calculate the answer by writing here the appropriate index. So this will be all. Now coming on to the code. So this is the code. So in this, first I have declared a variable b that so that all the bits in that should be 1. So I am ensuring that till n all the bits should be 1. So this is the frequency array, and the x which I am using is the prefix XOR, and this is how I am checking for every perfect square the frequency of that array and adding it to the answer. And here I am incrementing the frequency. So this is the final result, that will be n into n plus 1 by 2 minus answer.